Hi guys, so in this lecture let's start with law of reciprocal proportion. Okay, so let's get started. Law of this is the fourth law. We are seeing under the law of chemical combinations. So this is law of reciprocal proportion. Okay, so this was given by Richter. So first let's get started. So three elements are considered. Okay, first is, let's say, CH4, H2O, and third is CO2. So two elements are chosen, let's say C and H. C and H. Okay, so C and H, these two elements combines in fixed ratio, or rather in fixed mass of oxygen. Okay, so C and H combines in fixed mass of oxygen element. Okay, so if we see the separate products of CO bond, which is CO2, and for HO it was H2O, so we can see that C and O in CO2, 12 gram of carbon combines with 32 gram of oxygen. Similarly, H and O combines together to form H2O with 2 grams of hydrogen and 16 gram of oxygen. Okay, so we can say that (16 gram of oxygen is there. Okay, so you can see that if we have the same gram of oxygen, let's say we have 32 gram of oxygen, which will combine with 4 gram of H to form a H2O, just applying unity method here. So for the same 32 grams of oxygen, C and H are combining in a ratio of 12:4 or 3:1. Okay, and if we see that in CH4, C and H are having the mass ratio of 12:4, which is again 3:1. Okay, so these two are same, hence this verifies our law of reciprocal proportion. So if we see the triangle, that in the formation of H2O, in the formation of CO2, and the formation of CH4, the law which binds carbon and oxygen via carbon and hydrogen via oxygen molecule binds the same carbon and oxygen via their combined molecule, which was CH4 in our case. Okay, so if we go and see the ratio in which C and H combines via oxygen, that was 12:4, and in the same ratio C and H directly also combines in the ratio of 12:4 again, or 3:1. Okay, so simply to put it in statement form, that when two elements combine separately with a fixed mass of a third element, which was oxygen in our case, then the ratio of their masses in which they reacted with the third element is either same or some whole number multiple of the ratio in which they combine with each other. Okay, so let's put the statement that when two elements combine separately with a fixed mass of the third element, then the ratio of their masses in which they reacted with the third element is either same or some whole number multiple of the ratio in which they combine with each other. In which they combine with each other. Okay, so next let's see Gay-Lussac's law. Okay, so this is actually applied for ideal gas. Okay, so the volume of all gases should be measured under similar conditions of temperature and pressure. So in that case PV equals to nRT, hence V is directly proportional to N, which is number of moles of the gas. In this case V is directly proportional to the number of moles of gas at constant temperature and pressure. Okay, so gases combine in simple volume ratio, and if product is also gas, then their ratio is also simple. Okay, so gases combine in simple volume ratio and if the product is also a gas, then their ratio is simple. Okay, so let's see an example. So if we have CH4 and 2 moles of oxygen gas, they combine together to form CO2 gas plus 2 moles of hydrogen gas. Okay, so let's say this was the initial volume. We have 1V, 1V, and they are not present. So V is just a, you can say a liter also. I was just denoting any unit of volume here. So what will happen next is, finally we would have, this would be exhausted, and finally we would have 1 liter of CO2 gas and 2 liter of hydrogen gas. Okay, so next let's see Avogadro law. So actually finally we would also be having half mole of or half liter of oxygen present in the mixture. Okay, or which half would be present rather? This one or this one? Exactly, this half would be present. Why? Because for every mole of CH4 we need 2 moles of oxygen gas. So for every half mole of, or every half liter of, in this case CH4, you need 1 liter of CO2 of oxygen. Okay, and half moles of CO2 would be present, and only 1 mole of, or in this case 1 liter of H2 would be formed. Okay, this would be the final state. Okay, so pardon me for the wrong information in the previous when I wrote the previous answer. Okay, so Avogadro law. So Avogadro law is, if equal volumes of gases under similar conditions of temperature and pressure combine, or rather stay, then though that contains same number of molecules. Okay, so let's understand it via help of an example. If you have a hydrogen gas and chlorine gas, they both combine to form 2 moles of HCl gas, then equal volumes of gas under the similar conditions of temperature and pressure contains same number of molecules. Okay, so let's say this was 1 liter, this was 1 liter, and the form would be 2 liter. Okay, if we have 1 molecule of H2, if we have 1 molecule of Cl2, then we will have 2 molecules of HCl gas also present. Okay, then in the next lecture we'll be seeing empirical formula and molecular formula. So we'll meet in the next lecture. So even if you guys are not able to understand all these laws, so it's actually not a big deal as far as the syllabus is concerned, because we will be facing a lot of questions based on the applications of these concepts. Okay, so even going into that much theory and definitions of these laws, everything is just not recommended. We'll be practicing on the same concepts again and again, so only the practical questions and application based questions on the concepts which we have discussed in the law of chemical combinations would be asked. Okay, so this was just a very simple laws. So we have to just remember the form PV is equals to nRT for ideal gases, and all these laws will, all the previous 3 laws will come in place for us if we just remember this form or this equation. And for the previous laws, like we discussed reciprocal proportion, multiple proportion, these can just be read for the covering just for the syllabus of JEE, but apart from the theory perspective, nothing too high level would be asked in the examination. Okay, so this is just to clarify if any doubt you may have. Okay, so with this we'll meet in the next lecture.